class. I'm Gabriel Erijesu by name, and today we're going to be treating three topics in mathematics. The first one is LCM, the second one is fraction, and the third one is binary. So, first and foremost, let's look at LCM. Let's solve LCM. And hearing LCM, what does it mean? It means lowest common multiple, and it is the smallest number among all the common multiples of two or more numbers. In LCM, we have two methods. It can be calculated through two methods. The first method, we have the multiple method, and the second method, we have the prime factor method. Now, some examples have been given. The first question says, find the LCM of 4 and 6 using A, multiple method, B, prime factor method. And the second one says, find the LCM of 30, 45, and 90. You can see the second question, it wasn't specified, that says you can use any method of your choice. Now let's go on into the calculation. Question 1A says, find the LCM of 4 and 6 using A, multiple method. Okay, number 1 is 4 and 6. Then let's look at the A, multiple method. Now we look for the first thing we should do is look for the multiples of 4 and 6. 4, then 6 is going equals to. Now we have the multiples of 4. We have 4, 8, 12, 16, 20, 24, 28, 32, 32, 36, 42, and so on. Then for 6, we have 6, 12, 18, we have 24, we have 30, we have 36, we have 42, we have 48. So let's stop at this for now. Now let's look at the multiples. What are those ones that are common? The common multiples between the two of them. Let's say 12 is common here, is also common here. What else? We have 24. We also have 36. So our common multiple, according to what we just solved now, is equals to 12, 24, and 36. LCM. I said before that LCM is the lowest common multiple, and we have 12, 24, and 36. Which is the lowest? We have 12. So therefore, LCM equals to 12. That's that for multiple method. Now let's look at the prime factor method. Number 2. That's 1B. Prime factor. Prime factor method. Now, this is what most of us are familiar with. We are familiar with this. Now let's look at it. Drawing the table, are 4 and a 6. Take it down. One thing I tell my pupils, whenever they are solving this method, don't start with a big number for you not to get confused. Take it from the lowest number that you know can divide both 4 and 6. They can divide the number you're given. And the lowest number you can use to divide 4 and 6 is 2. Now let's look at it. How many 2 can we find in 4? That is, how many times can 2 go in 4? 2 in 4 we have 2. 2 in 6 we have 3. Now what else can go? We have 2, we have 3. 2 can go in 2. 2, make it of 2. 2 in 2 is 1. 2 in 3 is impossible, so you bring down the what? Bring down the 3. Now we have 1 and 3. What can divide? Only 3 can divide. 3. We bring down our 1 because we're gotten to the final solvings of it. Then 3 in 3, 1. Now there's nothing for us to divide again. We have arrived at 1, 1. Once you get to that point in your solvings, that is, you can go ahead to look for your LCM. Now LCM is going to be equals to The numbers, the digits we use to divide through are going to be what will multiply. We have, what's the first one? We have 2. The second one, multiply by 2 times 3. Now let's look at this. 2 times 2 is what? Is 4. 4 times 3 is what? We have 12. So that's that for prime factor method. Now let's look at the second question. It says find the LCM of 30, 45 and 90. In this way you can see it's not specified which methods you should use, and I think that's going to be in your common entrance questions also. A method is not going to be specified for you. It's just there for you to decide the one you want to do based on the time free coins that you have. Now, for me, I'm going to be using the prime factor method. Question 2. We have 30, 45, and 90. Okay? 30, 45, 90. Draw a table. Just like I said earlier, I said you should start with the lowest number that can go in all of them, or about 2 or 3 of them. And the lowest number that can go is 2. 2 in 30, we have 15. 2 in 45 is impossible because when you say 2 in 4 is 2. Remainder, okay, yeah, there's no remainder. 2 in 5 is to give us remainder. So it can go. What you have to do is what? Bring down the 45. 2 in 90. 2 in 9 is what? 4. Remainder what? 1. 2 in 10 is what? 5. So that's how we get our 45. Let's look at what can go in them again. The next lowest number that can go, 2 cannot go in them, so we have to use 3. 3 in 15, we have 5. 3 in 45, we have 15. 3 in 45, we have 15. What other digits can go again? We can make it of 5, but not to confuse ourselves. There's a lower digit that can go again. 3 can still go in 15 and 15, so make it of add 3. 3 in 5, we bring down the 5. 3 in 15 is 3. 3 in 15, that's 5. 3 in 15, 5. Now, what can go in between all of them? 5 can go. Make it a 5. 5 in 5, 1. 5 in 5, 1. 5 in 5, 1. I said the other time when we arrived at this stage where we have 1, 1, 1, that's the final stage. The next thing is to what? Look for the LCM by multiplying the digits used to divide through. And the first digit we have is 2 multiplied by what? 3 times 3 multiplied by what? 5. Let's look at it. 2 times 3 is what? 2 times 3 is 6. 2 times 3 is 6. 6 times 3 is 18. 18 times 5. Let's take it. 18 multiplied by 5. 5 times 8 is what? 40. 5 times 1, 5. Plus 4, 9. So that says 18 times 5 equals to 90. So therefore, LCM equals to what? 90. So that's that for LCM.